Here are two of these generalized projection operators for S3 or D3, symmetry group of the triangle. And let's use these in order to decompose, say, the span of these functions phi. The functions phi are the say, Gaussians that sit on the corners of the triangle. So the phi1 here sits in corner 1, and then the OE, the O operators, would just move the Gaussian from corner to corner. So let's apply P 1, 1, 1 to this phi 1. And we get 1 over 6. OE does nothing, leaves the phi 1 in corner 1. OC moves clockwise, so we get phi 2. OC bar moves anti-clockwise, so we get phi 3. Now O sigma 1 is the reflection across axis number 1 here. That leaves the phi 1 invariant. The phi 2 is the reflection across this axis here, so we get phi 3 here, and reflection across axis 3 moves the Gaussian down here, so we get phi 2. Now each of the functions appears twice, so in total we have 1 over 3 phi 1 plus phi 2 plus phi 3, and that's a function that is invariant under the action of all these operators, so it transforms in the trivial representation, and that's what we have to find if we apply this projection operator for the trivial representation. Okay, let's repeat this with the P2, the sign representation. Let's apply this to phi 1. We get essentially the same except for these minus signs. So let's just copy this, and the only difference is that now we have minus signs here, so we have to change these last 3 terms here to minus these terms, and now everything cancels, so this is 0. And we already knew that this space here contained no vector transforming in this sign representation, and that's what we also found here using this generalized projection operator.